So today is ODL lab number 11, and today we are talking on the soldering SMD. This is a very important session. This is being recorded, and hopefully I will upload this on the YouTube channel also. But before I start the soldering and I turn on my soldering iron heated one, we will talk on some of the problems you are facing. And before I move on to the problems, two issues which are here in the Ateeb's and Fahad. Ateeb's PCB was the smallest one, and I ordered it before Eid, and now it arrived yesterday. And then I ordered also this Fahad's PCB. Now, those of you who are not familiar with this thing, you can turn off this by signal layers, and now you can see only the. Now, those who are saying that it has a less number of jumpers, I saw some of the comments in the WhatsApp group also. The number of jumpers are huge over here. Some are very long over here. There's a 1, 2, 3, 4, 5, 6, 7, 8. This is a very long number. 9, 10, 11, and you can call it like 12, 13, 14, 15, 16. So something like 17 or 16 jumpers are there. Yes, Ateeb made a problem over here. He did not made it mirror, so that's why when you see the image of the PCB which I share, it was not mirrored, and then they printed it. This was actually mirrored in there. Now, practically, if you see over here, he has done two mistakes over here. In fact, you can call it three mistakes, because if I turn on all of my layers over here, this is the block connector, and you must have done this mistake. I have been asking you from very day one in experiment number 2 and 3. I told you that your manufacturer, if it is EPCB.pk, I told them to make all these block connectors approximately of 3 mm cross 3 mm, and I asked them to make the hole size at least 1 mm, so that when you are going to the dia hole size 1 mm, so that your block connector can go in. Now everyone is actually complaining me, even Al Jalil PCB yesterday, 2 or 3 students, they messaged me on MS Teams that the whole size they have delivered. Now Al Jalil PCB, I know them very well. I have been working them with for the last 15 years. They never drill two different sizes in their PCB. They drill only a common size 0.9 or 1 mm, and they give it to you. Unless and until it's 100 pieces or more than 500 pieces plus for your PCB, then they can do that. Otherwise, the single PCB, they just drill out a common size and they just give you. So now, if you are even giving to Mukarram or Al-Jalil PCB or EPCB or anyone else, please make this pad equal to 3 mm over here and 3 mm over here, and make this whole size, I have not made it whole size, equal to 1 mm. Okay? This is very important. So over here, now when I will make it 3 mm here for this pad size, Ateeb, if you are listening me, you can have an idea on this one. Now you can see there is a contention, so you have a problem. So you will have to edit this a little so that there is space over there. Plus I did not make it 1 mm, so this is 1 mm. Now this was one issue. Okay? The block connector cannot be placed over there, and this is very, very close to the yellow dot metric. So maybe there may be a size constraint. So maybe you have to move this one a little away from it. Okay? You can do it afterwards now. The second problem, which you can see, or I don't know how many of you have noticed this one. This is my, let me zoom out. Now, this is my power supply section area. Now, what is happening over here? This is VCC. This is going into this 78M05. I hope this is correct. One biggest mistake Ateeb has done, he has put a jumper here. Now, this jumper overall, it's easy, but for amateurs like you who are actually going to solder it, it is going to be a difficult one, and you have to take a jumper from here and then you have to connect it. I don't know where it is connecting it over here. Okay, this is not connecting anywhere, but where this is connecting, I don't know where this jumper is connecting. Ateeb, if you are online, please confirm me on this one. Why this via is pad, simple pad is placed over here. What's the reason of putting this pad over here? I don't know. It's drilled, but I don't know why you have placed it over there. Now, secondly, this one is the output, this one is the ground. Now, when you take this output, you have attached this one LED over here, and then from this one, you are taking a very big jumper wire to up till this point. And where is the 5 volt capacitor? I can't see the the 10 microfarad or 100 microfarad capacitor over here, which was asked over there. You have the SMD LED, you have this one over here, but where is the capacitor over here? So I can't see that capacitor over there. If this is that capacitor, Okay, you have placed that capacitor over here. So this is one over here, but one capacitor, if this is 10 microfarad, you are going to, I don't know, you have used a small size over here for 1206 size over there. So this jumper wire is a little big. So this is one of the flaws over here. And why this pad is placed over there, please answer this one maybe on, if you can answer this one on MS Teams, this would be good. I don't know, the session is okay. Okay, yes, it's working. So this is one or two flaws over there in this Ateef's PCB, as you can see over there. Otherwise, it's a very good PCB. Now, if I move on towards row number 20, what I did over here, he had done the same mistake, but not in that manner. I could not see the capacitor output. This was the output, and this one was the capacitor added over there. Now these are very close to each other. So what I did over here, I changed this to 3 mm pad, as you can see, and I added 2 more capacitors. Now one thing very important, you are going to learn this maybe in your next classes or semesters. On the output, whenever there is going to be a regulator and you have something like over here, and you are having a capacitor just like this one over here. So this capacitor, one capacitor is not going to be enough, add 2 capacitors. Why 2 capacitors? One capacitor is going to be like 100 microfarad or 10 microfarad, and the other one is going to be small. Small by mean picofarad or nanofarad value. Now why this is so? I don't know, you have studied up till now circuit analysis and design, and you have been told about capacitive reactance and inductive reactance. Now, if you remember your capacitive reactance formula, that was Xc equal to 1 over 2 pi, 1 divided by 2 pi Fc. So if C value is large, Xc is going to be small. So if you are going to use a small capacitor, then Xc value is going to be different, and if you are going to use a very large capacitor, Xc value is going to be different. So when you are talking about large currents, now what is a capacitor? Capacitor stores the voltage and gives that voltage whenever the circuit requires it. Or in other words, it actually stabilizes that voltage on that capacitor or on that 5 volt line. So if you are going to use a big capacitor, that big capacitor is going to be used for those currents which are huge. But whenever there is going to be a requirement for very small currents, that is actually, or very small, you can call it ripples in your voltage value. I don't know, you have gone through this ripple word or whatever. You have to use a small capacitor. Okay? If anyone cannot understand this, Google this out. Every time there is a regulator and one big value over there. So that's why I added this one on this one. The pad size I have also made it over here little bit one. And overall the PCB of this Fahad is, I like this PCB. Overall the size is little larger, but there are only 1, 2, 3, 4, 5, 6 and I guess 7 and 8. So only 8 jumpers. So technically this is a little better PCB with dimensions a little larger, as you can see over there. There are just some outside portions over here. But overall, it's a better PCB. But one thing very important, if you will see this PCB over here, if I just zoom in over there, one thing is a small manufacturing also difference in these two. This one, the Ateef's PCB, if you zoom in this one, the pads over here are, as compared to this one has a smaller visible pad. This one has a little fast PCB. Now this is the masking over here, and this rule can be changed from this design rules, and when you go on this mask, this is the paste mask expansion. Now in the Ateef's PCB, I asked the PCB.pk to don't have this expansion, which means that the pad is there, it must be of some size, whatever size may be, but you have to expand the area so that the solder can have some place on the fiberglass or something. So in the Fahad PCB, I have made this one approximately something a 0.18 mm, a little bit increase. So you can see physically also, this PCB, the pads are a little more sized. This one has a little small size. You can see, I guess you can see very easily see the difference over there. So one thing very important, I have asked ePCB also that whenever these PCBs are going to come to you for manufacturing, please make the SMD pads a little larger, because you are going to use this wire. This is the SMD soldering wire which you are going to use for this purpose. I'm just going to show you. I'm trying to open this one actually. Okay, this one. So I don't know how many of you can actually see this one. I'm holding it in my hand. This is a very, very small size. This is 0.4 mm. So the wire size which you have with you in your toolboxes we have given you, it is 0.8 mm. This is a very small size. I will just use you in front of you. So this is a very small size over here. So this is a better one, and this is the same roll over here with me over here, and hopefully if university opens, and we have a lot of them in our lab, so don't worry, we'll give you this for the assembly soldering. But if you can't get if the university does not open and the situation again aggravates or whatever happens, then I will tell you from where you can get this mechanic. This is 0.4 mm, still again made in China, but still a better quality. You can see the ratios of the lead and the flux inside it. Now those of you who have been sending me the PCBs and they're telling me that it's very messy, you can see the flux value. The flux value is from 1 to 3%. What is that flux? Flux is that same paste which you normally use over here, the same paste I have been using, this flux paste. So whenever you are actually burning this or melting this solder wire, you are actually having some flux dispelled on your PCB. So that's why it makes it messy. So you can use thinner, you can use some petrol or something like that, maybe some perfume, so that you can actually clean that PCB afterwards. So this is very, very important. So I will using this one. Now this is thieves and whatever. So I don't know who has voted for this one, which PCB is the better one. I can't decide on this one. So hopefully I will go with this one, I guess Fahad's PCB, because this has the pads visible more, so it will be a little bit easy. But for Ateeb, don't worry, I will, if I will find all my components, I will make both of these PCBs maybe in some free time. So I will turn on this whole PCB and all that structure, both of them. Before I move on to the other part, that is I'm going to talk on the experiment number 5 PCBs. So these are the revised one which have been submitted to me. Hopefully by tonight I will give you that revision one, and hopefully I guess some of them, I guess 2030 will be approved over here today in this result. Now if you see over here, maybe like for supposing, let's check, I don't know, roll number 16's PCB is still not here. Where he has gone, he has not submitted. Ateeb, you are again late or whatever you have done. Anyway, let's check for roll number 20. We have submitted it. It's a very good PCB. I saw this yesterday. Overall, it's a good one, and as you can see, it's just a size of 100, and by again 100 over here. The PCB is good. Now, one thing very, very important. If you can see over here very carefully, this one, the pads again all are blue in color, so this will make it a little easy for soldering. What I mean by soldering, because when you are going to use a female header can be easily soldered on one side, but on the other side, if you want to solder it, it's going to be a little difficult. I will show you in the next lab when you will have one of these PCBs made, any one of you. So then I will show you that it's easy, or if it is only solderable on one side. Otherwise it can be soldered, a little difficult, but can be done. This is a very good PCB. Overall the fill area and all that one has been done good. Overall the values of resistances and capacitances. One thing very important, whenever you are asking me to approve it, I have also shared this one in WhatsApp group also, that if I approve it, this means that it is okay by the design. Okay? By design, I mean that okay, the pads are okay. You can see it's straight, lines are straight over here, and this is connected on the top. I don't know why you have done this one on the top, because they are going on. Okay, it's okay. It's going on the back over there, well and good. So this is also going on the back side. So this is solderable on the other side, very good over here. So this is okay. But I can't check the schematic. Okay, this is very important. You have to do it yourself. This is your, because I have seen 2 or 3 cases. I guess the philosopher was there and he has done a big flaw in his experiment number 2 PCB, and then there have been other cases also from Al Jalil PCB. Yesterday a girl student told me that she has done some issue again. So please check your schematic. This is very, very important, because if you do a blunder, you are actually wasting your almost whatever the cost of that PCB, maybe 1,000, 1,500, whatever. So you are actually wasting your money. So this is very, very important, and I have also told you please make this name of over here at least of 0.33 mm. Okay, this is good. So apart from the spacing, it's okay. So please every time make this 0.33 or 0.35 mm width, and the height I told you 2 mm, but if its space is not there, 1.7 mm is still okay. But I guess there's a lot. And one thing very important, if you are putting it in bottom layer, mirror it. If you are putting it in top layer, don't mirror it. This is very, very important. Okay? And when you are going to order, and those who are going to order this experiment number 5 PCB, especially those who have not been approved for experiment number 4, they are actually also going to order experiment number 5. And those who will be told on after 20 approximately for experiment number 2 and 3, I will be telling them that experiment number 5 is not going to be done by everyone. It's only for those who have not done the soldering and the running part of experiment number 2 and 3. So I have told you previously also in the group also before as well that experiment number 2 and 3 was for everyone, 4 is also for everyone, 5 is only for those students who are going to have the experiment number 2 and 3 not done, or not approved, or not working. All 3 of them. Experiment number 6 is also going to be for everyone. For 7, we are not going to do that one again because that will escalate the cost a lot again. For experiment number 8 and 9, we will approve it over there for both of them. But half of the class will make experiment number 8, half of the class, which means half of the groups are going to make experiment number 8, and half of them are going to make experiment number 9. And as far as the projects are concerned, by the end of this week, I will tell, and those who have been very good in this all experiments up till now and up till we allocate those projects, we will relax them for the project. So maybe those who are very good at these experiments, we won't ask them to do the project, because the concept of the project is actually to make you work on the soldering part, the designing part and all that. So if your experiments have been very good, there is no need to do doing the project. We will just give you the scaled marks over there, or the average marks, whatever you have scored over there. But we will set that threshold criteria. I'm doing this one so that the burden economically wise, it's going to be reduced on every one of you. Okay, so this is one PCB, one issue, experiment number 20, I guess roll number 20, I guess he is some of good students. So let me just take some other students over here. Maybe 54 you have submitted, like you can see 4 or 5 designs. Anyway, I'm taking the latest one. Okay, sorry beta, you can see now what you have done. You can see what problem. I guess everyone can have a look over here very easily. The vias. The vias are, I have told you previously also, they have to be 2 mm. They have to be 2 mm. Then, so when you will make it 2 mm, you will make it 2 mm, you will make it 2 mm. All vias are going to be made 2 mm. This will be having contention, so it will be having a problem. So please, this is again rejected. Whoever this is, roll number 54, please correct it. Certainly when you are going to do it for revision 2, you will have some marks reduction over there, -1 out of 10 for this one. And again, you can see all of those who are having this problem, you can see what is this one. Now it will be manufactured, no issues, but if it stays in that ferric chloride solution for a long time, it will have a track broken. So please always make it very, very important that you don't make this. This is still an orthogonal track, so I will avoid this one. This one is anyway, so you have to edit this one. So one problem, and again another issue in this one, you can see very easily why this long jumper. I don't know from here to here where you are taking it, but this is connecting. So this is maybe a missing track or something like that over there. So see, if I am approving this, I'm going to approve it for the fill area, I'm going to approve it for the pads, the vias, the placement of components, but I can't check the schematic. This is very difficult. You are 160 or 170 of them, your students are there, 160 I guess of there. So I can't check each and every schematic. So this is your area, you have to do it yourself. Even if I have 2 or 3 TAs with me or GAs with me, still we can't check it. This is very difficult for me to actually check it. So please, whenever you are ordering the PCB, give it a double check yourself. This is very, very important that your PCB is running without any issues over there, because I have checked 5 marks for the working of the PCB. Again, one issue again seen over here. You can see why this is like this. Both are connecting with the same track or same pad. So why you are taking another one? It can be just one. And whenever you have something like this is a capacitor, you are going to heat it more. So just make a small fill area. Just make a small fill area over here. This will enforce that your PCB, even if it isn't not the double layer PCBs, they are not going to be in bakelite every time, because bakelite is only available in single layer. So this is always going to be fiberglass. But still, when you have a fill area, it can't be eroded. Now, all of you who have submitted your pictures and all that, I will go through them later on. So you will have an idea on this one that when your pad is small and you heat it more, it can be eroded off easily. So this is also one issue. So whenever, and one thing very important again, if you are seeing this one, roll number 54, I don't know what's your name. So this one, the ground track, it has to be big. It's coming from the regulator. Again, an haphazard track. So these are very, very important things. Please make this correct on your part, because I have told you roll number 54, it's not going to be approved anyhow. So you have to make it approved. So you have to change these PCB's design. I will take one more on anyone wants to check his or her PCB. You can tell me your roll number. Beta, the field Zafar, I'm seeing your comments actually. Beta, you can default pad and wire size. Yes, you can change it. You can change it. I guess it can be done in this tools preferences. I guess you can change it here. Somewhat here, I guess there's a models, I guess general, it can be changed. I will tell you on this one. Actually, I never go through that one every time, so you can do it over there. Okay, I'm just going to go with row number 87. Row number 87, just maybe the field. I will come on to you that default size afterwards. You can ask me later on. 87, okay, 87. Okay, you have also submitted 2 files, but anyway, I am taking the last file. Okay, 87, good design. Overall, management is good, but let me just see on the all. Now, whenever you have to actually check on the design, I don't need to see the components, because I'm not checking the schematic of this. Now, this is telling me very easily that top layer is not even used. It's not a very good PCB from that point of view, because you have not used the top layer much. You have not used the top layer much. And you can see, let me just verify, this track size is 0.6, okay, 0.7 should be there, but anyway, 0.6 over there. So this is the, I guess, the regulator over there. This is that, overall it's okay, it seems nice. The fill area or the 5 volt, I guess this is the 5 volt line. Yes, this is okay, and I guess this is the ground, if I'm not wrong, because this is going, yes, this is the ground, good overall. 87, I guess this is a nice PCB, unless and until there are some other issues. If there are any schematic issues, you will have to see it yourself. And overall, one thing very important, these, I guess these are the male headers. I told you specifically that make the male headers, but since your PCB is already a very large PCB, so these are on the top layer. Anyway, aesthetically it will be a little difficult, but anyway, blue switch, ULN 2803, green switch, red switch. You have also added dips over there, so you can check this PCB very easily at your home also with that 9 volt. Okay, any other roll number you want to check? Let me just check from the list. Okay, roll number, let me check roll number 7 actually. Okay, let's check roll number 7. I will take 2-3 more, and then roll number 7 again. You have submitted 3 files. It's a very huge PCB, beta. First of all, 120 by 120, it's a huge size. It will cost a lot on your pocket. Fill area only used there, but its connection, now see the problem, what you have done. You have a 5 volt region over here, and then it is not connected over here with a very good track over here. You can see in this area, this is only connected with a small. यहाँ पे आपने बड़ा fill area use कर दिया, यहाँ बड़ा fill area, इनके दरमियान में क्या है? You can take it from the side and then over here. I guess this is Habiba over here, the name of the student. So you have this problem. So fill area is inconsistent, and you have done, again, I have told you previously also, please avoid these slanting tracks. Track should be originating straight and then going on. Again, you don't have space over here, you have a space over there. Make it far, because when you will be soldering it, this is very important, you can mix two tracks over there unless and until it's not masked. Okay, so this is very important. So you can make it again straight like this. So this is okay, you can increase the size a little bit more. Plus you can see again, this is not a slanting track over here, so this one is very close, you have to make it far over there. Overall, the PCB has a lot of vacant spaces. One thing very important, if I have to give some marks to this PCB versus the last PCB I showed you, and then the last PCB over here, this one was in fact pathetic. This one is, I guess, the best one. Up till now I have clicked 4 of them, so this one is the best one. I will give the second to this one and maybe third for this one. So you can see very easily that, okay, here you can see these 3 tracks are very close to each other. You can make somehow some arrangement over there, and again you can see over here you have space over here. So why can't you make it like this? It's easy, you can make it, you can extend this one. This actually, whenever many manufacturer, remember this thing, whenever any manufacturer is going to open this PCB, and that manufacturer is going to say, oh, this is very close tracks, very difficult to make. This again very close. Instantly you will have 200-300 rupees cost increased. This is, I know them. Al Jalil, I have sent many PCBs, hundreds of PCBs I have sent to Al Jalil, and whenever he sees that PCB, oh, this is not possible, it's going to be very expensive, so he already gives me a rate more than 2k or 3k plus. But if you have managed it PCB and you have made the tracks far apart, because before you have to make a positive of this PCB, if you are doing it by ultraviolet, or if you are even using the toner transfer method or whatever, close tracks, difficult to etch, difficult to make. This is very important. So every manufacturer, whenever it sees the PCB, you are going to have a lot of cost increase if it is not. बनेगी या नहीं बनेगी वो तो बात की बात है, क्लोज होने की वजह से वो एच ही ना हो, प्रॉब्लम आ जाए कोई उसके अंदर, मास्किंग सही ना हो सके, कुछ हो जाए, दैट्स अनदर इशू, बट the cost is already good. And one thing again I am pointing out, I have asked you, this is 0.5 mm, 3 mm, okay, this is good. Overall, you have wasted the space actually, Habiba. If you see very carefully, you have no track on this one. If I change this one, only in the center region you have the top layer. In the lower region, no track on the top layer. So this is and you can see in this area, I won't call it haphazard, but unevenly distributed. This is very important. Okay, and you have to then, and again, this is almost an orthogonal track. Kindly avoid this one later on. This is again very close to this one, and you can see this is not straight. It is not straight. I guess the pad can take it. So come on, you can have actually, you have this one. Let me just, and you can extend this one like this, the straight line now. And again you have space over here, you can make it far over here. Okay, so do this one, and I guess 132, I don't know why the comment is the best PCB, man. Let's see 132 if it is the best or whatever. Let's see 132. Okay, good one, I guess, very good one. I won't say, okay, no, sorry, I take my words back, comments back, because the wires are not 2 mm. Please, this is very important. Wires have to be 2 mm. Now, when I will make them 2 mm, you see what will happen. Contentions. Okay? So you will have to make it again, I guess. Sorry, 132, the PCB is not very good made. You have very close tracks. You can see over here 1, 2, 3, again wires over here, and I guess you are all very much dependent on this auto routing. Please get out of it. You have to adjust your PCB designs The software, remember your motherboards or your PCs, or your laptops or your mobiles, if it was auto routing, you won't be having a very good smartphone of just like 5 mm thickness or 6 mm thickness in your hand, or maybe just in your palm. It is the engineers who are actually designing it. If it was auto routing, then you would be having a mobile of maybe like just your that old Parktel size or something, a size of handset, something very big. So please use auto routing for connections, but afterwards do use your brain to actually make those tracks far apart from each other. Again, can't this be made straight from here? So I guess this was very easy. So no need of bend over here. So you can make it, you can correct it afterwards. So over 132, I guess this is again not there. Okay, roll number 69, you are asking for the PCB checking. So roll number 69, let's check what you have done. Wow, very messed up, but I don't know, your manufacturer is going to see this all holes. They are going to say, okay, it's going to be a difficult thing. But anyway, let me just change it to that layer. Seems okay. Achha, every time whenever you are seeing it, you can off the one layer also. How? These are top layer and bottom layer. Double click at this one. I want to actually only see the bottom layer, so I will click OK. These 4 tracks almost equally spaced, not that issue. This one very close. These two just make it a little away. Maybe just up till the pad. Now the space is the liquid. Again, don't make this notches over there either. Connect it straight like this, because again remember, notches again problematic. Again you have this small variation, you can see very carefully. These notches actually accumulate ferric chloride. Overall the PCB seems okay, apart from not a zigzag. Okay, this is okay, not an issue. This fill area is not uniform again over here, because this is 5 volts, I guess. This is 5 volts, and you have not connected, I guess, with the ground layer. Where is ULN? I guess ULN is this one. So ULN, this one. I guess you could have extended this fill area. You could have extended this fill area right up till the bottom. Okay, and then just taken a fill area over here. So that would have been a good thing. Okay, so you can use this one. Your name, Shuja, I guess this is your name. So you have not followed this. This is again still 0.254. I asked you for 0.33 or 0.35. 0.35 is better. And you have also not made it 1.7 or 2 mm. So when you will make it 2 mm, you can see the size will increase, and you can place it here. So no issues, I guess. You can place it here. So that's not a big issue. You have space over there. Wherever you have space, you can put anything. Okay. So this is very important. You can put your space anywhere whenever you have over there. I guess there is an issue. Okay, there is no issue yet. So I guess. Okay, partially you can call it maybe just some minor changes, but overall it's okay. After this is number 69. Let's just check 177. I guess 177 have been. Wow, what is this? Sorry, beta. I asked it for a 2-layer PCB. Your name is Mohammad Rihan. You have not followed anything up till now, and this seems what you have done. I don't know what you have done over here. This is the pink color fill area. Why you have put a pink color fill area? I don't know. Sorry, beta. This is totally wrong. 177. Please, will have to do it. You will have to spend some time on this one. You have not used the top layer. You have contentions over here. This is very close to each other. Please, whoever is having a mic turn on, please do not turn on your mics over there. Row 177, highly disappointed by your PCB. I don't know what your performance in the last few experiments. Roll number 170. Let's check 170. 170 has been asking. Okay. So I am getting some very messed up PCBs, but this is very congested. But overall good, I guess. First view, but I will just first of all turn on. Oh my god, your manufacturer is going to take a lot amount of money, because whenever a manufacturer sees this type of tracks and this type of tracks, be very careful. So, and you have a lot of vias. You have a lot of vias. This is a very good technique of actually using it, but inconsistent fill area. You can see you have I don't know, this is 5 volt. So make this fill area also big, because you are putting that 5 volt from here to the transistors and then to it. So make this fill area. I don't know where your regulator is. So your regulator is here. You are taking this fill area up till here. So make this also big. It's good. And whoever this is, I guess Mohammed Fazan, or 170, good one. Just some minor changes, but your manufacturer is going to be a little in problem. Okay? Anyway, you get it masked, because otherwise when you are going to get it soldered, it's going to create a very big problem. Okay, let's just check now 2-3 more, and then I will move on towards the soldering part. Let's just check roll number 71. Oh yeah, wow. Again some messy things coming up, and let's just change it to signal layers. And again some haphazardness. You can see again this is not straight. I have asked you, it should have been straight up till now. The name I asked you, this has to be 0.33. One thing I told you, if it is in bottom layer, it has to be mirrored. If it is in top layer, it has to be unmirrored. So this is very important. You have done a mistake over here. This one 5 volt line, why this is not uniform? This is a very small area. Can't you move this track a little bit here? So this is uniform, and this is going towards the 5 volt line. I don't know where is the regulator. Again, you have used a very small track. So can't you move it? I guess this is very easy. You can move this via a little down. And I guess, okay, this is a little, and you can extend this track up till here. So why make a small area? So some issues, okay? Some issues I can find out, some issues maybe I won't be. And one thing, why this is like this? This is red and blue. So either it is in red or it is in blue. It is in both. So this means there is some problem over here. Either your software has done this problem, and this software does this problem. So please kindly check it and connect it in whatever this is the. Okay, I guess I will have to use my own tracks over here. This is still. You can correct it yourself. So this is also again over there. But I can't take so much requests over here. Row number 71, I just took it. I will take any one from here, 178 or 179. There's, I guess, some foreigners or maybe like that. I don't know, 179 I'm taking it. Wow. Shahzeb Zafar seems okay. When you will solder it, you will actually understand what issues you are going to commit. Again, top layer not used very beautifully. Only bottom layer is used, so top layer has to be a lot over here. So I don't like that much. As far as the top layer is, bottom layer is concerned, these tracks are very, very close. So maybe the manufacturer will be a little displeased by them. And why can't this be in a straight line? Why this is a bend over here? Why these transistors are slanting down? These and I have told you very also much that as Sir Bilal is pointing out, you cannot place a via on the component, and those components, if they are dip switches, certainly you can't, because dip switches will be directly soldered. For ULN 2803, you are going to use the female header. So this is very important. Overall, it's a good PCB. I guess again you have not mirrored it, beta Shazed. You have to mirror it if it is in bottom layer. Okay, if you are making a 2-layer PCB, it will be better if your name is on the top layer, because then you manufacturer, please make this one the keep out layer. For 2-layer PCBs, this is very, very needed, because when you are going to have it in keep out, it will be printed. When they will get it printed on this positive or whatever, they will have the positive, relative all will have the keep out layer on them. So this is very much important that you have all this one as the keep out layer. So this has to be, okay, my mouse is actually having a problem. So this has to be keep out layer. So this is very important. Overall, a nice PCB, Shazid. Don't see much problem, but all are connected on the top layer. All are connected on the top layer. So I guess how you are going to place it, I guess. So you will have to solder everything on the top layer. So it will be a problem, but anyway, this will be okay. Okay, I will just check one more, I guess. 106, let's check yours. 106. Those of you who I have pointed out the problems, please start working on it. And by the time the result comes or the revision 1 results comes, I will point out more problems, or if it is approved, whatever that case may be. Overall good. The RGB is going in one other area, otherwise it's good, not an issue. Let me just change it to over here. Top layer again used less, but overall okay, not bad issue. Again here this is a congestion, as you can see, congestion is there. So can't we take this track from somewhere else? No, it can't go. You can see again this is a little mismanagement over here. And okay, seems okay, but you have space, you can take it a little up. Please, I have told you the text has to be 0.35 and the larger the better. 2 mm is the minimum, but if you don't have space, a very small PCB just like SMD one, then you have 1.7 mm the limit. This is mirrored, okay. This is 5 volt. Please, for RGB dot matrix PCB, even if it is SMD or whatever, the fill area for 5 volt and ground is a must, because RGB dot matrix is going to take a lot amount of current. So this is very important that you can actually have the PCB running. This is very important. This seems good. Why this is a small pad over here or fill area actually? Please see this one. So this is 106, and I guess I will take one more, 166, the last one, and then I will move on to the soldering part. Roll number 166. With a very large PCB, vacant spaces over here, vacant spaces over here. Otherwise in this area seems okay, but you have not used the fill area. The one thing very important, why only connection with this one? You can place a big pad over here, oh sorry, fill area, and again also a fill area over here. So this will be easy, okay? So even the drill is there, and then you can actually have a pad size. So, and I have asked you, please make all block connectors, whatever PCB you are designing, even if it is the SMD or whatever, the RGB or through hole components or whatever, please block connectors 3 mm pad size with 1 mm hole size is a must. Okay, this is very much important. Manufacturer is not going to do it, and this will be a problem. So at least afterwards you can argue, because if you have sent it without the hole size over there, you can't argue with the manufacturer that they have not drilled a hole according to the size, because they will do what you have sent them. Overall this seems okay, beta. Whoever this is, Abdullah, I guess. Seems okay. Not that messy. I can't check the schematic, but overall seems okay. This one is good. Okay, you have space over here, so why can't you increase the fill area so that it's covering all the pad like this? That will be better. And the regulator with the 5 volt, I guess this is not having that good connections over there. This is very small, and then you can take this with a very thick area and then take it on that side. Here you can see the connections. They are not even connecting, they are only connecting with the pad over there. They should overlap. This is very important. The two should overlap. This is very much important, that your tracks or whatever, no, I can't make it more, but actually I can move this via a little bit here. So they should overlap. This is very important. Otherwise this via is not going to be in some very good over there. So overall, I guess I have pointed out some mistakes which are there in experiment number 5. You can place components such as resistances under the RGB dot matrix, no issues over there. This seems okay, no issues over here. These are also straight, I guess. Some arrangements are getting better. I guess I have been busy with experiment, the yellow dot matrix PCB and the experiment with 2 and 3. And as I've told you, don't use this slanting, use this one. That is actually okay. So this is one. So this is one PCB, okay. If you want to give a better look on this one, just see one layer first. That's how I actually see it. You can see this is a little bit more close. These are again close, and you can see these three are also again very close. I don't know why you have used a fill area. This must be some, okay, this is ground. So if this is ground, this has, and if it is going to take a lot amount of current, then it should be a big fill area. So this is one problem over here. So if this is connecting, how with this one, I don't know how this is connecting. So maybe there is a schematic flaw, beta. Please, whoever this is, Abdullah, I don't know, but ground is here. How it has reached this point? Maybe I guess to the top layer it is coming on. Maybe that is also. So this is important, but it should be more thick because this is ground. If it is connecting over here, otherwise seems okay. And who is this one? Roll number 162. Okay, this is the last one now. I'm not going to take anyone else. Roll number 162. 1, 2, 3, 4. Oh, wow. 4 files submitted. Roll number 162. Okay, beta. Nice PCB used over here. You have used that male header pin over here so that the PCB connector, you have abolished those dip switches, I guess. So that's why your size is also reduced, but you have not used fill areas. This is, I guess, 5 volt. So 5 volt connection. This is the ground connection. Seems okay. Thick area, but the 5 volt connection, okay, here to up till the 0.1 over there. Seems okay. Not that bad, but seems okay. Not an issue. So I guess a well designed one. I must say this is nice one. And what are the sizes of this one? Let me just check. Something near about 90, and this is something 97. I guess this is 8. That's 90 by 98, 90 by 97 something. So it's a good size. I guess this is the smallest one I have seen up till now. But you have abolished the dip switches, so you won't be able to check it very easily over there. Again, these block connectors are going on the other side, so this will be solderable on the top side. So be very careful when you are actually going to use this one. Seems okay. The ground connection, so quite well managed. I would say this one, if dip switches are not there, so then certainly this is a good PCB. Okay, so now I'm going to move on towards the, this is all, so I hope everyone can, I'm just going to save none and this is all. Okay, so now I'm moving on to the soldering part. Okay, I still have not found some of my elements, and now since I have this one, this is my vernier caliper, I'm going to put this one away. The first thing, I'm actually going to use the Fahad's PCB because that's a little easy for me because the pads are a little bit. Ateeb, don't be disheartened. I will solder your PCB and I will certainly show, I guess there is a small PCB green masking coming out of it because I put some on it. Okay, so Fahad Habib, I guess you can see this and everyone can see this one. Now, when you have this SMD PCB, the first thing first, I guess, has to be the jumpers. So the jumpers have to be connected first. So I have, first of all, I will turn on my soldering iron because that's the most important thing at present. And when I will have this PCB from the front side, you can see I have this PCB over here on this one. So you can see the holes are drilled over here. I guess, yes, this is only one hole over here. One thing, the PCB connector holes are not big. This was one, I edited it, but I could not do it at big hole size. So each PCB, they have not sent me the hole size big. I will just do it myself. I have a drill machine with me. So this is the PCB, and first thing I am going to do, I have turned on and I am going, actually this is the okay, so I hope everyone can have a look on this one. Actually my handycam is not turning off. So I have this jumper wires. Now I'm going to make this jumper wires first, and meanwhile I will open the PCB actually of this row number 20, which is the edited one with me, so I can know which jumper wire I have to connect. So how many jumper wires I have to make? 1, 2, 3, 4, 5, 6, 7, 8. Okay, the first thing first, I am going to make this jumper wires first, because jumper wires first and then the SMD components, and at the very end I will put this male headers over here, and then I will put SMD components. First of all I will put the vias, then I will put the SMD components, and then I will put the male headers. So everything is SMD, but I could not find this 78M05 transistor. I brought it last week, in fact before Eid, but I could not find it where it is at present. But anyway, I will show you how I am going to solder this one in front of you. How many jumper wires I need, I will again verify from here. I need 1, 2, 3, 4, 5, 6, 7, 8. So I need 8 of the segments over here, 8 wires over here, and they are quite large wires. So what I will do, I'm just stripping off some of the insulation from the jumper wires over here. Okay, so I have one, and let me just show you on camera what I am doing actually. So okay, and one thing very important, since I will be working on SMD, I have turned off my fan, and you can see over here I have a tweezer. Now this tweezer is very thin, pointed out, so that's why I have put it in some plastic cover. Plastic actually cover comes with it. So this is very important that you have tweezers with you. Now I know you don't be having tweezers. Maybe if girl students are hearing me, I guess they have this tweezer. Sometimes they actually use this tweezers for, I guess, some eyelashes or something like that. I will tell you a shop where you can get these tweezers, but if you are working in Maker's Lab, we have a set of 6 or 7 tweezers over there. And tweezers are very important because you are going to place the resistors on SMD resistances on this PCB using tweezers, and then you are going to actually solder it over there. So this is very important. So I will now just cut some jumper wires over here which are required over here. This is 1, let's just have 2, then I have 3, I have 4, 5, 6, 7, 8, 9. Okay, so just I have 9 of them, just in case if I miss it over there. Okay, so now since this is the image in front of you, when I am holding it, this is the PCB right here in front of me, like this is that PCB here in front of me, and the image is here. So there is going to be one jumper from here to here, which is exactly on this one, from here to here. Let me just zoom it a little bit more so you have an idea. So this will be a jumper from here to here. So I will just put a jumper wire from here into okay, so I have this jumper wire connected, and then I will just see there is another one from here to here, which means on the from here to here, and this will be let me just confirm it. Please, anyone, if I do some mistake while doing it, please write down in the chat window or ask Sir Bilal so I can know what mistake I have done, because I'm doing it on camera and sometimes it can be a mistake. So I'm going to put all the jumpers on it, and I'm going to so this is a simple jumper over here. So 2 jumpers are added, you can see, and then the third one, I need a very long one here for this one, I guess. this is going to be a long jumper. I'm talking about this one at present. So this is going to be, I guess this is going to be a very large one. So let's just talk about something else. But okay, I have to have one jumper from here to here, which is certainly on this one from here to here, and then this one to this one. Yes, if I'm not wrong. Yes. So this means I have to connect from here till here. I will just bend them afterwards. I'm not going to bend them just now because actually I don't have a jumper wire this much long. I will just cut it afterwards. Then I have two more jumper wires, I guess, one and two here. So on the camera, this is going to be this one with this one, and then this one with this one. So certainly this means I'm going to connect this one with this one, and then there is this one. Okay, so I have this one. I guess I have missed the above one also. This one is also a jumper. Okay, yes, this one is also a jumper. So I'll just put another wire here on this one. Okay, so only one, I guess this is also one jumper wire. Let me just confirm on this one. Okay, yes, this is also one jumper wire. So this one to this one. So this is going to be another one from this point. Okay, so I have now, apart from this long one, I have everything jumper wire over here. So what I'm going to do now, I'm just holding it in my hand, so I'm not going to actually. So one thing, I'm going to now press these jumper wires, and for this purpose, please use a steel ruler or something like that, so they are with the, so you can see I've tried to press them, and this is a little bit away from this one. You see I have some blood also coming out now because I just poked my finger inside these jumper wires. So this is the jumper wires, and I have tried to make it, and I can just put it upside down and just press it again. And now let me just the soldering iron is hot. Let me just check it. Okay, I have it, and I am going to open my solder wire. There's a lot of, so now you can see I just cleaned my bit over there. So I'm just going to solder this one here. So let me just zoom in a little bit more so you have an idea what I'm doing and how I'm doing. So you can see very small blob. Now I'm soldering this portion. I hope you can see this one again with the same technique, like this. And again I want to solder this one like this, and if I want to solder this one, not a very good one, but anyway, yes, this one. One thing very important, I have cleaned this PCB as soon as it came to me. So you can see now I'm just making a small hilltop. So you can see now what I'm doing on this one. I'm only moving my wire. I'm not moving my soldering iron. And then actually I can't see much here because I have not turned on my light much over here. Okay, so you can see the masking has an important thing. So with the masking, the solder will not go in the area where it is green color, okay? Or the masking color, whatever that masking color you have. So I'm going to just, so you can see With masking, the soldering is very easy. And whenever you have the PCB with you, please clean it with some petrol or thinner or something like that, because if it arrives with you maybe by 2-3 days, oxidation can start and then it can be difficult for. So you can see now I have almost soldered almost all of the jumpers. Only 1 or 2 are left, and that one long jumper over here. So I guess I have soldered everything. I hope so. So I have only just one left from here to this one. So I guess the jumpers are there. So I will just I have now blood coming out of my hand, the same finger I poked in. Anyway, I will just take another jumper and try to put it inside, and I have it over here. This is coming from here. Be very careful and okay, so I'm just going to put it again, and you can see now. So in fact I have missed one over here. So this is going to be one end, another one. So you can see now very carefully all soldering has been done. Let me just zoom in a little bit more. So in fact it can't be zooming more, that actually blurs it. So I guess everyone can see this one. You can see all of these are very small hilltops, not that big. So you can see from the side view also, as I am showing you, this is a very simple soldering. So I will just find my cutter. Actually my cutter is a little away, I guess, in my lab. Let me just get my cutter so I can actually cut this. But anyway, I can use this same orange cutter with me. One thing very important, when you are going to cut this is very important that you cut it from the edge over there. Okay. I guess I have missed one solder. Actually I wanted the other cutter, but I could not find it. Okay. So you can see I must missed this one. You can see I have missed this one where my finger is. So I'm just going to make it again. So you can see my what there, and I can just now peel off this one. So my jumpers are ready. The jumpers are ready. So the next thing let me just have this a little bit clean. So now I have this one, holding it like this. So now I guess first thing we should now put the UL and IC. So let's just put, because let's start from some easy thing. Resistors are a little bit difficult, so I will go with the UL and IC, and UL and IC is going to be placed here. And now I will show you how you are going to use your forceps and all that. You can see this is a very small tip forceps, and now I will take the UL and IC. This is that UL and IC with me, and be very careful. Please do not open SMD components. They should be on a table. You will lose them very easily. You will lose them. They always come in this tray packaging. This is actually a tray sealed packaging, as you can see over there. And don't use your hands over there. Sometimes you can have a cut. You can see my fingers are cut over here because of those wires or whatever. In fact, there was a small bit before as well. So I'm just going to peel off this one over here, and I need one IC. Now one thing very important, you are going to have, or you're going to pick one IC from here. It's totally up to you. Be very careful. Never pick your IC from the legs. This is very important. And place it on your one. And do it one. and again place it for the remainder of your component, because these SMD components, they can be lost very easily. Now as you can see over here, and now I'm going to turn this a little bit in this side. Now if you zoom in very carefully over here, this is that IC which I'm going to do over here, and this is going to be placed like this. Now let's just confirm first on the design that how this IC is placed over there. This is the dot over there, and certainly I don't know how this is going to be placed over here. Let me just zoom in a little bit over here. So this is that first pin, I guess, or second pin, I don't know how you have used it one. This is the input, and this is the first pin, and the camera, I have this one. Let me orient it again like this one. But again, this is the bottom layer, so you have to have it something like this. So this is the input side. Remember, this is the input side over here, and certainly this is the input side from the microcontroller that is going to come. And here, this is the connections going on to the resistances, and then taking the current from the LEDs and then sinking the current. So certainly this orientation is okay. So it has to be placed IC over here. Now let me just zoom it a little bit more so I can show you the soldering part carefully. Okay, so you can see now ULN 2803. You can see I'm holding it by the the forcep over here. Now how I'm going to pick it? Okay, now you can see now it's aligned. Okay, now if you are not a professional, since you will be two persons in one group, I will ask you to put some scotch tape over here while pressing this one with the forceps. Okay? Don't use your fingers, because sometimes in your fingers you will have some electrostatic discharge, and that can actually destroy your PCB. Maybe not ULN 2803, but for your future uses when you are going to have an SMD. Now, whenever you are going to have something like this, what I will do over here, I will take this bit over here, the soldering over here, and I will have some solder burned connected to the tip of my soldering iron, and I'm going to so what I have done, I've just done one pad. Now this is not going to go anywhere. Okay, so now I can take, oh sorry, it is still going anywhere. It was very still not connected over there. So let me just, so SMD soldering is going to be a little messy thing. So okay, so I'm going to hold it with this forceps in my hand, and assuming it's still hot. So okay, still it's not joined. Maybe I have actually I'm a little away from the PCB, so it's getting a little, actually I don't have much light on the PCB track. Okay, so you can see what I have done. I've just placed one, but it's a little actually let me just orient itself according to my okay. So now this is connected. Okay, actually I am trying to show you also, and I am very away from the table edge, so that's why my hand is also not very carefully on the, so you can see now this is there. So now let me just put 2-3 edges more, and then will be, and now I'm going to take some light actually. I don't know you people will like this or not because of the lighting brightness, but actually I need this one. So one way in which you can actually solder this one is this one. Now this technique of actually doing the soldering like this, in which I am actually shorting out each one of them, is called as drag soldering. Now this is a very important term. You can see what I have done. Now you are shorting it, but what I am going to do now, I have picked up the solder wherever it's excessive, and I am dragging it. Clean your PCB, sorry, the solder one. This drag soldering is easy whenever you have some very fun. So just I guess one more blob, and I can use a sucker over here actually very easily, but I have tried to. I will just do it in just one way. So this is another view for you. In fact, let me just, I don't know how many of you can see this. So again I am first of all I am putting the solder, and then I am going to, so you can see now solder will automatically stick wherever it's needed. That is actually the pad. This is the advantage of the SMD masking which you have done. Remember, your bit should be clean. So you can see what I am doing now. When I am holding this one, it actually attracts that excessive solder which is on the pads. So you can see almost all it's clean, but this one has to be picked up. Still it's not getting picked up actually. Let me just get my pad actually. My pad is in my toolbox. Where is my toolbox? I'm just initiating the recording again. So you can see now what I have done. You can see I have cleared this side. I guess this one is also cleared or not. Let me just check on this one. I guess still some blob is there. So I guess you can see here, this one is a little messy here still. One thing very important, when you pick something up in this solder iron, okay? Just like this I am picking up something, the excessive solder. You can do this with a solder wick. I will show you that one maybe in the next class or something. But whenever you are going to pick something up, don't bring that solder again back, because when you are picking it up like this over here, okay, have a little on the solder iron, थोड़ा सा झटका मारें आप उसको, so that that solder iron, the solder which is stuck to it can be actually peeled off. So I guess this is the IC soldering. As you can see over there, this is done. There is no connections with this one, and I hope this is connecting over here. This is still going to do, I guess. Let me just do it in this direction, so this is going to be easy for me. And whenever you are doing this work, one thing very important, I don't know how many of you have this flux with you. You can apply this generous amount of flux over here on the IC pads, and in this way your PCB will be actually saved, because you are actually heating it up. So this is very important that your PCB is saved over here. So what I have done now, just so you can see all the pads are now soldered over here. So you can see there is no connections with each other. Same is the case over here, same is the case over here. It's a little messy, over here, because the PCB is not clean, but I will clean it afterwards. Okay, so I'm just zooming it out now. Oh sorry, I'm just zooming it out and turn off in fact this one and take this one. So I don't know how many of you. So this is the PCB, and you can see this is connected, this is connected. You want to clean it off, you can do it with your thinner or something. Use a small brush, don't non-abrasive brush, simple brush. Now the next thing, I guess we should put some resistances now then I will go on towards the transistor. So if I go on towards the transistors and resistors, let's put the big resistors first. What are these big resistances? These are the big resistances which are connected with the ULN2803, and if I go on the circuit diagram, this resistance has to be 10 to 33 ohm, 1210 size. So 10 to 33 ohm, any value which is going to be put over here, wherever these are the big pads, 1, 2, 3, 4, 5, 6, 7, I guess 7 and 8, yes, 8, 1, 2, 3, 4, 5, 6, 7, 8. So these are the places of the resistance. Now let me just check first that 1210 size, which resistance I have available with me, which I can use in the 1210 size. So let me just check with me the value of resistances. This is 10R, I have 100R, I have 47R, this is 47R small size, this is 47R big size. Okay, let's use 47. I have shown you, I've asked you for 10 to 33. In fact, let me just check. Maybe I have 33R also. I will use 33R. I won't go for the larger value, because larger resistors means that I will have less illumination for the yellow dot matrix. So certainly one thing very important, 33 ohm resistance, 1210 size. Yes, I have it. So you can see I have got it. How I know this is 33? First of all, the shopkeeper has written it. It's 33R. So this is 33 ohm resistance. And if you just zoom out in this one, in fact, this is written 330. The value written on this one, I don't know how many of you can see this one. If I even zoom it on, it's not going to be very visible to you, but yes, this is 330 written on this one. So you can see that this is a 33 ohm resistance. You can Google it out, the SMD nomenclature or the way on which the value written on this one, and this is 12Z10 size. This is 1210 size. So how many of these are there? I have 1, 2, 3, 4, 5, 6, 7, 8. So now it's a very delicate thing. It's even smaller than the IC which was here. So very carefully I am going to peel off the above layer on this one. So this is very important that you peel off the plastic layer which is on this one. Now as soon as I will peel off this layer, this resistance is going to be falling down over here. I'm trying to actually get the plastic removed in one go. So and these resistances are not that expensive if you are going to buy them for 1206. Okay, I have now peeled off the resistance, the cover, you can see. Okay, and some resistances are falling. This will happen. This is very important that you have a table on which you can actually put them carefully. Okay, so this is empty now. Just make sure you are 8. Now please do not take out more than what is required by you. So you can see now I have all the resistances over here, 1 2 3 4 5 6 7 8. And whenever you want to actually turn this upside down, be very careful, because if you are going to put at this edge like this over here, and you press it, it will fly away from your table, and I have lost a lot of resistances from here like this. So be very careful. Hold it, and okay, not like this, like this. Hold it, like this, and hold it like this. Don't try to, this is a very delicate resistance, okay, and you will have to have a lot of patience. Maybe some of you would have lost the patience that the IC is not getting soldered, so this is going to be a problem. So I have now 8 SMD resistances. Now I'm going to solder one first over here. So what I'm going to do, I'm going to pick now which is the terminal side. As you can see, this is one terminal, this is one terminal. So I have to place this resistance, which let me just confirm first on the design, because you have to keep your design with you always. So I have this one with me. So the SMD resistance is, this is 1 2 3 4 5 6 7 8. So the 4 which are with each other, let's just put first here. These are the 4 ones. So I know this is 1. So I will pick one over here and pick it from the non-conductive side like this, and place it on over here. Now let me just bring them over here so they are in my camera view, so you can actually see what I'm doing. Now one way is this: you take your solder wire, okay, in your hand. You have placed the resistance on the pad, have your soldering iron with you, clean the tip. Okay, my soldering iron is at present, actually I told you it's having hot and then cold air coming simultaneously, so this is going to create a problem. And here I'm going to show you the both ways over here. Now since the resistance is so small, I can even manipulate it with my tip and the soldering iron, as you can see. And let me just use my forceps now. So one end is connected, so just turn this PCB so it's facing towards you. And pardon me, I actually don't have much light source over here with me, because when I turn on the light source, the your vision actually becomes obscured, so I'm not. So you can see now, first of all I placed one end, hold it with the forceps, and then I placed it over there. So this is difficult, but the advantage of using an SMD is enormous. Now again I'm going to put another one. Let's just complete this 8 one very fast. And one thing very important, I have done a mistake that I have put this all 8 over here on this side. Please put them somewhere a little bit apart, because sometimes they stick to your hand, and when you are going to lift your hand, they are going to be actually falling off from your table. So I'm now going to place another one over here like this, and okay. Okay, so what I did, I just put a small pad over there. Actually, again, just try to make it as straight as possible, otherwise it will touch. So you can see now the masking is going to be helping me. The solder is not going to go anywhere else. Okay? So you can see now the I can now place another one. Let me just be very fast on this one. So and I'm going to place this one here. Okay, so let me just put, now I'm doing another way. First of all, I will put some solder on the pad, pick the forceps, pick the resistor and melt done. So you will learn this one as you will do some SMD soldering. This is another one, and then I will do the fourth one actually. I don't know if someone is okay, and this is my fourth SMD. So again, your tip should be clean. SMD components, they will stick to your soldering iron if you are not going to clean them. So this is very much important. So a good forceps very much is going to be better for you. Oh, sorry. I just turned it upside down. It will still conduct, no issues, but it will be better if it is straight, because sometimes when you are going to debug your PCB and you will find out, okay, the 330 ohm resistance you attached actually something a different value, then that will be problematic for you. So you can see now 1, 2, 3. This one is a little directionless. I don't know how many of you can see this one, but so I'll just put. So I hope you can see this 4 SMD resistances. They are soldered over here, as you can see. You can see some flux over here, and which is sparkling, and this easily tells you that so this is one. And now I will just put the remaining 4 of them over here. Let me just confirm again what are the remaining 4. I guess I have done this one, so I need to do this 1, 2, 3, 4. So if on the camera, which one are those? This is 1, 2, 3, 4. I guess this is 1 with this one, and then 2, 3, 4. Oh yes, 1, 2, 3, 4. Okay. So 1, 2, 3, 4. So this one has to be now my PCB is actually now having some flux, so that's why my forceps is also showing that sticky thing. Okay, there is one easy way of soldering this one also. I will show you that one also, but you can't try it at home. You will have to come to the department for that purpose. I will show you. And that process is it requires a heated oven or a heated plate. I don't know how many of you are into 3D printers or whatever. Just like a 3D printer, you will require a heated plate where you can actually solder these ones. How you are going to do that? What you do, you actually put paste on all of these pads, the SMD pads actually, and then when you have placed the paste on that one, you placed all the components by your tweezer and put the whole PCB inside the oven or that heated plate. It will have some temperature, certainly 200 plus degrees centigrade, and all that paste will melt and become a solder. So in one go, all of the SMD components are planted. But if you have done one mistake there, everything is gone. So this is a little difficult over here, but as far as the basic industrial manufacturing is concerned, that is done using the heated plate method, and that is a little more easy one as compared to this one, but this one is, that's why I am not asking you for the experiment number 7 PCB. I am just asking you the experiment number 6 PCB, which I am actually doing at present. So my aim is that you should be actually capable of soldering SMD components, because the next age which you are going to have, through-hole components are obsolete now. You won't even find them on a good websites such as Texas Instruments or something like that. You won't be able to find it even. So this is very important, and actually I have lost a lot of my eyesight has become weak over the of time. So, but for you people, actually I'm not using any light source. Otherwise, when I use a light source, this whole picture which you are seeing at present will be a little more brighter. So just for you people, otherwise I can do this soldering at a very fast pace. Because normally nowadays I don't use the through hole components much now. Okay, just missed it. So this is my third, the second last resistor actually. So this is that one, and the last resistance which I am going to place now is going to be, so I have now the last resistance to be placed here. So actually what happens, you can see I have placed that SMD resistance, but as soon as I will put heated iron and that soldering wire near that pad, it will get away and I will have to not very straight, but see, I'm not using any microscope over here, so I don't need any arguments from you that okay sir हम नहीं कर सकते हैं और हमारे साथ ये problem है और आपके पास तो camera है और ये है, and I'm doing it without any light. My table is not illuminated at present. So you can see now 330 ohm resistances, 8 of these resistances connected over here, and they are working. I hope so they are working, not an issue over there. Better yes, you can use tape. I guess there is not an issue of not using a tape over there. So now I will do the 2N3904 resistance, sorry, the transistor over here. So the transistor over here, 2N3904, I will just show you 2 or 3 soldering over here, and then maybe we can have this. Now over here, see this one, this is a very important one. The transistor is very, very small. You can see this one is a very, very small transistor. So I will just get some scissor actually. Okay, I have a scissor over here. And this is again a cut tape. So I am going to cut only one of these transistor, because I only, or maybe like 2 of them. Let's just have 2 of them. Okay, so again, it's a very difficult SMD soldering, so please put them always in some sealed packaging. So whenever you have to open them up, and all the 2N3904 resistors or transistors are here. This is 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 over here, and certainly these are 1 kilo ohm resistances. I will just show you one of them also over here. So now when I'm going to peel this off, it's a little difficult to actually peel this off from here, but, and those of you who may be having this idea in their head, you actually came in electrical engineering to learn electrical, but सर हमसे मोतियाँ लगवा रहे हैं या कुछ इस तरह से कुछ कर रहे हैं. It's not something like this. This is a very delicate work. I know this work has to be done by by some diploma technician or something like that. But remember, your work, whichever you work you are going to do or ask someone to do, you have to do it first yourself, and then afterwards you can say, okay, now what I'm going to do now, see this very carefully. I have placed that transistor over there. I'm going to place the pad a little bit of solder on it. Okay, you can see I've placed, if I can zoom it a little bit more, maybe, okay, I've done it, yes. Now I'm going to have the transistor picked up, and assuming it, I have it over here. So what I have done, I hope so I have placed it correctly. So you can see now it's not moving. So I have, what I did, I just placed some solder and then picked it with a forceps, and now I'm going to do the other 2 pads soldering. Now my solder iron is actually now dirty, so I will have to clean this up. So, okay, now this is there. So the back pad, which is actually, I guess, if I'm not wrong, it's the collector, which is going to take the current. I'm now going to actually move some light on my source. Sorry about that. Actually, I need some source over here. I actually can't see because the transistor is very, very small. So you can see now what I've done. I have done this pad over there, this pad over here, and this pad over here. So you can see now the transistor is connected over there. Okay? And I'm now going to place another transistor. Let me just do that here, and then I will put the 1 kilo ohm resistance. It's already 4 p.m. So I won't take much time Afterwards I will complete this PCB, of course, and hoping that I can do this one today, so hopefully I can have the okay. See, I just picked it up and the transistor flew there. So please, whenever you are working on this one, please do not pick the transistor from the edges. This is very much important, because in this way the transistor will actually be flying off somewhere else. So now as you can see, I'm going to place some SMD solder on the pad. Pick the see what I've done. My SMD transistor flew off, and the good thing is it's still in my table area, so I have now brought it back. And so be very careful with very delicate hands. This has to be done. So okay, so this is done, and now I'm going to first of all solder the back side now. So let me just confirm. And remember one thing, if you have to debug something on SMD PCB, it's very difficult. Okay, so I don't know how many of you can see this one. I'm now going to show you on the camera, so you can see the transistors are connected. Okay, so two transistors are connected very carefully on the 2N3904. Now this one is a 1 kilo ohm resistance, if I'm not wrong. Let me just confirm it on this one. Yes, this is a 1 kilo ohm resistance. So I will just put a 1 kilo ohm resistance in front of you, because that is going to be of 1206 size, so it's again smaller. So I'm just show you that 1 kilo ohm resistance, how you are going to put that one. And so this is that 1 kilo ohm resistance. I don't know how many of you can see this one. There is written 102. This is 1 kilo ohm resistance. If it was 103, then it would have been 10k resistance. If it was 101, then it was something 100 ohms resistance. You can see this one on the Google, the shaped there. Again, I will just show you two resistances over there. So I will just going to cut the two pieces. Be very careful when cutting it, because again it can fly down anywhere else. And so I have now again two of them. The tweezer is going to be again helpful here, because I am going to pick again the plastic covering on this one. This is very important. Okay, so I have successfully peeled off the plastic covering. So you can see I have now 102. Easy way around, put it somewhere on your table, or maybe okay, so I have just put it here. I have both of them lying on this one, and I have now 102 resistance to be soldered like this. So this is 102 resistance. Now I will just show you how you can, first of all, again I will do the same transistor thing. I will use the same, clean off the one, put some solder, hold off the okay, and now I can solder the other end. my solder iron actually needs some wood. So when you have done the other end, then you can actually remember one thing, don't put excessive solder. What I have done over here, I have placed a little bit more solder, so you can see it's a little bit big blob, but anyway, it's not going to be problematic. So now I will put the second resistor. And one thing very important, if you are placing the resistances, if you have placed it 102 this side, please place all the resistances in the same direction. It looks good. Secondly, when you are actually going to debug the PCB and you are going to be in a problem, then when you will see, okay, 102, 102, 102, everything is in the same line, it will be easy to debug, because sometimes you will put in place of 102, you are going to put maybe like 103 or maybe something like that, so that will be problematic. So this is my resistance, again 102. I guess the second way is little easy for me. So you can see now I have placed 102, 102 very carefully on this one. You can see a lot of flux. You can see it is shining from on the surface. So this is the transistor and the 102 resistance, the 1 kilo ohm resistance connected over there, and then at the end I will solder it. In fact, I will try to record this again over here, so don't worry on the I will try to record this one. I guess it's approximately 4:05 now. So any questions, G? Any questions from what I have just done over here? So because only 97 students are here at present, so this is very important. Any questions, beta? You can write down in the conversation window over here. I will try to record this one because the session is being recorded still over there. I will try that it is recorded, maybe not with my voice, but I will try to record it and do this whole soldering. If you are there, I can record it. I can try to complete it 20-30% more over here at present. This one, the difficult portion, I guess, is this transistor and this transistor, which I still have not found. I have to actually find it out. One thing very important, this transistor replacement is 2SA1213. Okay? Actually on the Hall Road, this BC869 is not available now. So 2SA1213. I have actually also shown this one in the previous classes also, that this is a PNP 2SA1213. They both have almost the same parameters, nothing different over there. I have actually got the transistors. I don't know where I have put them. I have so much mess around in my lab at present. Actually nowadays I am putting my solar system, solar panels at my home myself from the last 1 or 2 weeks, so that's why I'm actually a little messed up in my lab. So any questions, beta? Any questions from the audience? Please ask me. Or should I complete this ray of resistances over here? So one thing very important, whenever you are peeling off these resistances or whatever over here, like this one, what I have done, only peel off which you intend to do. Don't peel off excessive one and say हम बचा लेंगे उसको संभाल लेंगे, वो कभी बचते नहीं हैं. They will definitely be gone, and they will be flying off somewhere else. And sometimes my lab basket is full with some SMD resistances or something like that, and it's a big issue over there. And so this PCB is, I guess this should work. And one thing very important, yes, I guess I should do that. Since this is the SMD 78M05, which is still also not with me at present. I am unable to find it at present. These are the same capacitors I just told you. Now these are the capacitors, and I guess this is also one capacitor from here till here. I guess this is the ground, I guess, if I'm not wrong. What is this? This is 5 volts, sorry. This is 5 volts, and this one is ground. Let me just confirm it from the data. This one is 5 volt. This one is, yes, 5 volt, and this one is ground. So this means that this one is 5 volt, this one is ground. So ground, and okay, what you have done over here, this one is 5 volt. So this one is another capacitor, this one is another capacitor, this one is another capacitor. So what I'm going to do now, I'm going to put some capacitor over here. Let me find one capacitor. Okay, I found this 1 microfarad. Okay, I can't find 10 microfarad at present with me, but I'm going to put this 1 microfarad. See, this is 1 microfarad. Peel off one of the capacitors. Okay, I have just peeled off one of them. Pick it with your forcer, actually fell down, and keep it intact. So over here, and I'm going to now, this is a capacitor, and you can see by the shape of this one, again this is 12, 0, 10 size or 6 size, 6 size actually. So I'm now going to solder it here. So let me just first put some solder on the other end. So okay, so you can see now capacitor soldering is not that difficult because it's a big part, not that big. So you can see now, and now I can put some more solder here just to make it a little bit more. So you can see now the capacitor is attached. So this is 1 microfarad capacitor. Technically I should be having a 10 microfarad capacitor also here, but I can't find it at present over here. But anyway, the circuit is since just going to work, so this will be working fine over there. Any questions, beta, from this one? I have just soldered 1 capacitor. Fahad, if you are there, please kindly confirm me on this one. I have placed, this is a plastic piece over here just now. I guess this is that LED, if I'm not wrong. Please confirm me out on this one. This is that resistance, and this is that capacitance, and also this is that SMD pen. Please confirm me on this one, because this is going to be very important for me, and I guess this is that 10 ohm resistance over here, which has to be going towards one of these transistors. Yes, so yes, cool. Please Fahad, if you can confirm me on this one, this will be good for when we are going to do it. So any other questions, beta? Okay, 132, you were asking me on the IC dot connector side. Okay, let me just go on. In fact, let me ULN2803. Okay, I'm actually typing on the wrong keyboard. ULN2803A. So I need the data sheet actually for the SMD so that I know what I am doing. Okay, this is the ULN2803A, and okay, the dot where it is, it's pin number 1. So now coming on to my over here. Okay, this is upside down picture, so this is very important so that you are actually seeing this one. So when you have it, this is pin number 1, 2, 3 to ground. Now let's check it on our actual PCB, because that is actually important. So when I have this PCB here like this, So this is pin number 1, pin number up till 8, and then this is ground connection with this one, certainly because this is the 78M05 ground connection, and then this pin is empty because certainly this has to be empty, and then these are the connections. So I guess this is okay. Okay. So row 132, if you are having some apprehensions about this one, so this is okay, no issues on this one. So any questions ji? No questions? Acha, one thing very important now, I have the deadline for experiment number 2 and 3, the pictures and the working video. That deadline is already there, and that is up till tomorrow, up till 12 at night certainly. Those who will submit after that will certainly have some penalty on that one. And please, for experiment number 4, the deadline is, I will announce it in a day or two, but please get it done before the end of the this week. At least try to do it before at least the next class. And I have given you in this today's lecture the software link. It's actually a torrent link. I will upload, it's an 8.5 GB with the help of Sir Bilal. Sir Bilal will share you the link for the REVIT software. It's an Autodesk AutoCAD software from the Autodesk company, and in that software you can design electrical wiring and electrical installations diagrams. So I will not go through the whole software in this next 2 weeks over here, but by next week I expect that every one of you has installed that software. I have given you the torrent link, and I will share those who cannot download that torrent. I have that 8.5 GB set up with me and with Sir Bilal. Bilal, please contact me after this class so that we can actually make that pieces of 1 GB each, and then you can download it at your respective locations, and then you can install it, that 8.5 GB with crack certainly, and then you can actually open it. So the point of actually doing the software is this, that you can actually install, you can design your own electrical wiring installation, maybe for your home, maybe for any commercial building, maybe for any high-rise building or something like that. So the point of actually working on, and since you are not physically present in the lab and we are not doing any wiring experiments here in the Makers Lab, so the point is actually to give you a design methodology, and this is a totally new thing for your session. I wanted to introduce this last year, but again due to those online classes and not having a planning, this was not done. So please install this software, REVIT, Autodesk 2019 version I have shared with you. I'm not going to go the 2020 version and the latest one because that will create problems because they are still not mature. So the version which I have given you, install that one, and hopefully not on next Wednesday, I will have a small tutorial session recorded and shared with you by Sunday so that you can start working on that one. And maybe in the next class I will tell you to design one assignment. I will give you in the next class. In fact, there will be 2 assignments in this whole, in which you will have to design one electrical wiring for your house, in which there will be 2 bedrooms, 2 washrooms, and 1 kitchen and 1 lounge over there. We will ask you to do that, and then in the second assignment I will ask you to do it for some high-rise building or something like that. We will decide on that one depending upon how much you can absorb that software and how much you can do that, because our lab is the electrical and electronics workshop, and maybe in the next lab or after that lab I will show you some of the circuit breakers and fuses also. Maybe on camera I will show you about them, that how those can be worked on. And please gear up your speed on the PCB stuff over there, because I told you previously also that you have to complete 6 experiment up till from 2, 3, 4, 5, 6. This has to be complete before you come. Experiment number 5. So please spend some time on experiment number 5. Try to make it small, try to make it contentions free, try to make it better in design, and schematic has to be confirmed first also. So those people who don't have the working of experiment number 2 and 3, those who are have not got them approved for experiment 2, 3 and 4, they have to definitely make experiment number 5. So that is very much important. So acha, and one thing those who have not got approved experiment number 4, those groups in which both of the members, they have not got, any of them have got approved, they will have to do experiment number 5. That's a must. Okay? Because this means that the both members are not there. Those who have got their one member approved, okay, they can order now. I am allowing them to order. Those who have got one member approved, they can order now their PCBs, that member which is approved. We have the data, so don't order something else. We will compare it with our data afterwards. So those who are having one member in their group, they can order experiment number 4. Okay, I'm allowing it. I will give a list in the evening also. Those who have one member, I will share that list with you, but I guess you have already the list with you, so you can see yourself if you are approved and you are a part of that group in which one only member is there. So there will be some penalty to the other member who has not got that approved, but you are allowed to approve. So because I don't want the other member who has got it approved to be having some penalty, so certainly those जिसका approve नहीं हुआ है उसको हम थोड़ा सा penalty डालेंगे on the mark side. But I am allowing those students who have one group member approved, they can order the PCB of that student who has got it approved from us. Okay? So for experiment number 4, and please, today is 19th, by 20th, experiment number 2 and 3, the chapter should be closed by that time. And for experiment number 4, I will announce the date, and then I have told you previously also, please try to do it very fast, because experiment number 6 you have to do it up till that time. And for experiment number 5, hopefully revision 1, I will upload the results by tonight or tomorrow morning. Okay? So experiment number 5 is going to be done only by those whose experiment number 2 or 3 is not approved, not working, or I am not satisfied with their soldering. Okay? Yes, beta, for experiment number 5, yes, again, both students have to be approved. That is a must. Okay? Okay? This has to be approved by both of them. So this is very much important that both of them are approved. Any other questions, beta? From Google, REVIT 2019 from, I can't understand from Google. Oh, don't install the trial version from AutoCAD. It will create problems for you. That's why I'm asking you for the crack version. It will have some limitations on the working, such as nodes and the buttons or the electrical wiring you can place over there. So don't install. I will try. I'm actually downloading that one from the AutoCAD free trial version or the educational version, but I have a suspicion it will have some problems as far as the limitations are concerned. So don't do that. Okay? Do the torrent link I have given you, and I have that 8.5 GB file with me. In fact, let me just confirm if it is downloaded. Yes, it is downloaded with me, 8.50 GB. Yes, beta. Experiment number 6 soldering will be done by the other group member. This is very important, but let's just come up till that time. And I'm asking you this because I will share experiment number 6 results also for those who are actually there. This 16 and 32 you are already approved, I guess, because that's why your PCB is with me. Just minor changes which I have asked you. You can order it just now, roll number 16 and 20, I guess, not 32. 16 and 20 you can order it over there, but for the rest of them I will have there are better minimum requirements. I guess there is for this software is at least 4 GB of RAM, and it should be at least i3, and this will require at least a 10 GB space in your hard drive. So this is important. This is the heavy software. Okay? It's just like AutoCAD, a little downgraded version, but in the electrical frame it is working for the electrical windings over there. So any other questions, beta? So and meanwhile, hopefully I will try to solder this remaining portions over here, and then hopefully I will make a small video also for the running of this one. This is because when you have made a PCB, it should be running also over there. So I guess this is all for today. So already the recording has been done.